All right, so here in stable air, the temperature drops of the air about 3.6 degrees Fahrenheit for each 1,000-foot rise in altitude. Now, if the temperature at sea level is 70 degrees, write a linear equation that expresses the temperature in T in terms of altitude in A in thousands of feet. All right, so we're going to have some kind of a T of A. And what do we know? Well, it's dropping 3.6 degrees for every 1,000 feet. So basically, we're going to have 3.6 degrees decrease per 1,000 feet. So this says in thousands of feet. So that's really going to give us a minus 3.6 per one because that's one basically after you convert it to this thousands of feet. And so that's going to be our slope, minus 3.6, and that's going to be A. And at that first temperature at sea level, it's 70. So that means we're going to have plus 70. And this will be degrees Fahrenheit. So this one, they gave us the slope, and we just had to make sure we put it in the right format because it's negative 3.6 per 1,000 feet, but they want it in thousands of feet, so it's negative 3.6 per one. And so that's our slope times A plus 70. Okay, so that's our first question. The next one now says, what altitude is the temperature 34? Well, that's just take 34 equals negative 3.6a plus 70. And so we'll take 34 minus 70 and then divide by negative 3.6. And so it looks like 10. So A is equal to 10. Well, A is 10 what? Well, 10,000 feet. Or we could write it as a whole number like that as well. So depending on which way you want to rewrite it at the end, doesn't matter, but that's how it's going to be. Okay, so that was one where they do something a little bit different. Instead of giving you 2 points, they gave you kind of the slope, but you had to put into the right units to make it work correctly for this problem. All right, so let's stop there and come back for some more.